Hello everyone, I'm Hao Di He, and I'm excited to present our work DETR, DETRs with hybrid matching. Since the success of DETR on object detection tasks, DETR-based approaches have achieved significant progress on various fundamental vision recognition tasks. A key design for DETR is one-to-one set matching, which helps DETR to establish its end-to-end capability so that object detection does not require handcrafted NMS to remove duplicate detections. However, the one-to-one set matching also significantly reduces the training efficacy because only a small set of queries can be assigned to the ground truths. To overcome the drawbacks of one-to-one matching and unleash the benefits of exploring more possible queries, we present a very simple yet effective hybrid matching scheme. Our method introduces an additional one-to-many matching branch that assigns multiple queries to each positive sample. We find that this simple approach can substantially improve the training efficiency and the model performance. We named the hybrid matching approach DETR and verify its effectiveness using a variety of vision tasks as well as different model sizes ranging from ResNet and swing tiny to swing large. Our hybrid matching scheme can improve the detailed model performance across 5 challenging vision tasks, including 2D object detection, 2D panoptic segmentation, 2D pose estimation, 3D object detection, and multi-object tracking, and beat the state-of-the-art approaches in some tasks. First, let's review the general pipeline of DETR. Given an input image I, DETR first applies the backbone and the transformer encoder to extract a sequence of enhanced pixel embeddings. And then, DETR sends the enhanced pixel embeddings together with a default group of object query embeddings into the transformer decoder. After that, DETR applies a task-specific prediction heads on the updated object query embeddings after each transformer decoder layer to generate a set of predictions independently. At last, DETR performs one-to-one bipartite matching between the predictions and the ground truth bounding boxes and labels. Specifically, DETR associates each ground truth with the prediction that has a minimal matching cost and apply the corresponding supervision accordingly. The one-to-one matching avoids a handcrafted non-maximum suppression to remove duplicate detections, but it also slows down the training process because only one query is assigned to each ground truth object. According to our observation, deformable DETR typically only selects less than 30 queries from a pool of 300 queries. That's because nearly 99% of the COCO images have less than 30 bounding boxes annotations. The remaining more than 270 queries were assigned as non-object and are only supervised with classification loss, thus suffering from very limited localization supervision. This problem could be solved by changing the one-to-one matching into one-to-many matching. In the one-to-many matching, the ground truth is repeated for certain times, so that multiple predictions will be assigned as positive samples for each ground truth object, so queries can get more supervision. However, using one-to-many matching for training will let the model eventually produce duplicate predictions in the evaluation process, and a time-consuming NMS has to be taken to remove duplicate detections. So, what we need is to combine the advantage of one-to-one matching scheme in removing NMS with those of the one-to-many matching scheme in higher training efficiency. That's why we introduced hybrid matching. We introduced 3 hybrid matching schemes for DETR: the hybrid branch scheme, the hybrid epoch scheme, and the hybrid layer scheme. For hybrid branch scheme, we introduced an additional one-to-many matching branch when training, where we simply repeat the ground truth for k times and get an augmented target. We also perform the bipartite matching between the predictions and the augmented ground truth pair over each layer and compute the same losses used in the original one-to-one matching branch. To accelerate the training speed and process both branches in parallel, we further apply a masked multi-head self-attention to avoid the interactions. Therefore, we do not observe significant extra training costs in experiments. In the hybrid epoch scheme, we only maintain a single group of queries. We will apply one-to-one matching and one-to-many matching on the predictions during different training epochs. In the first certain epochs, we perform one-to-many matching to accelerate the training progress, and then we change one-to-many matching to one-to-one matching for the remaining training epochs to avoid duplicate predictions. In the hybrid layer scheme, we also maintain a single group of queries just like the hybrid epoch scheme. Instead of performing different matching strategies across different training epochs, we apply one-to-many matching on the prediction output by the first certain transformer decoder layers, and one-to-one matching on the prediction output by the remaining transformer decoder layers. From the precision recall curves on the left, you can see that our approach consistently improved the recall of the baseline on the 2 different IOU thresholds. From the right table, we can see that hybrid matching approaches consistently outperform the baseline on the different training apples, and hybrid branch scheme is the best choice if we consider the trade-off of training time, inference G-flops, FPS, and the accuracy. Therefore, we choose the hybrid branch scheme by default if not specified in the following ablation experiments. The comparison result on the COCO object detection validation set shows that our edge-deformable DETR achieves consistent gains over the baseline with backbones of different scales. Besides, we also report the comparison result on LVIS object detection in Table 2. Our approach also achieves consistent gains over the baseline deformable DETR across various backbones, like the swing large. We choose the very recent representative DETR-based approach, the PETR-V2, to verify the generalization ability of our approach for 3D detection based on multi-view images. This table summarizes the detailed comparison results. We can see that our edge PETR-V2 significantly improved the NDI score of the baseline PETR-V2 on new scene dataset, thus showing that our hybrid matching improves the localization accuracy of 3D object detection predictions. We also extend our hybrid matching strategy to the very recent PETR for multi-person post-estimation task and summarize the detailed result in this table. We can see that our approach achieves consistent gains over the baselines. We apply our hybrid matching scheme to a powerful multi-object tracking approach, the TransTrack. This table summarizes the detailed comparison results. We find the result on MOT17 suffer from relatively large variance, thus we report a mean performance with 3 rounds. Accordingly, our approach also shows strong potential on the multi-object tracking tasks, and our edge TransTrack improves the motor score of TransTrack largely on MOT17 validation set. We also observe that the gains are related to much lower false negative rates. Although our edge deformable DETR uses more queries, it has small training overhead on the original deformable DETR framework. This is because only a portion of the decoder computation is affected by the number of queries, which takes a very small percentages of the entire network flows. Also note that the more increases in training time is caused by the Hungarian matching, which is implemented on CPU, and the cost and loss computation steps, which are inessential, and we leave its optimization as our future work. This table reports the system-level comparisons to some state-of-the-art methods that use single-scale evaluation COCO validation set and choose backbones of similar capacity with swing large. By introducing additional enhancement techniques, our edge deformable DETR achieves the best on COCO validation set, which surpasses the very recent Dino DETR method as well as other top-performing methods. Thanks for watching.